Alrighty. Hello, everyone. I miss you so much. I'm so sorry that you were tuning in here in this capacity. But I just want you guys to know that I'm working really hard to make this the best possible scenario, the best learning possible from home. Um, I know it's less than ideal, but I really, really, really hope that these videos help. I hope it's just the same way that I would teach this to you guys in class. You're able to still see my screen annotation. So all that I ask is that you guys follow along, you do your best, try your very best, have what you need ready to go. And do your best to stay engaged with the lesson. I know it's hard when you're like looking at a computer screen, but at the same time, it's also hard for me just looking at a computer screen, not knowing how you guys are doing out there. So just know that I miss you all so much. I can't wait to come back on Tuesday. But we are doing the very best that we can. I know that I certainly am doing the best that I can. I have this inspirational video that I'm going to post on Canvas because I know you guys are getting burnt out, okay? But remember that we have come too far to quit now. We have about 5 weeks left of the entire school year. We can do hard things. I know it's rough. I know it's hard, but do not give up. All your hard work will pay off. You just have to keep staying up with it, okay? I got your back, but you gotta hold up your end of the deal of being a good, awesome student for me, okay? We can do this. Wanted to hop in really quickly to some homework, okay? So, your homework, you might feel like, oh my God, I have so much homework. I feel like your homework has been fair, but I do know that it's a lot. So, your homework due tonight, the guided notes from today's lesson. I need to know you watched this video. I need to know you got out of it what I expected. So that's why that's your assignment for tonight, is turning in your guided notes. I'm even going to school and dropping off guided notes for you guys so it's so much easier to take them, okay? That's due tonight. Sunday, I'm going to give you guys another Delta Math assignment. You'll see it posted on Canvas, but that won't be due until Sunday to practice the skills that we are learning today. Okay? And then, real quick shout out to this cute little kitty cat right here. Peep its tongue. The tongue right there, its little tongue. That is actually going to be the graph of cosine today. So it's another reason why I chose that little GIF here. So let's keep it rocking and rolling. Let's move into graphing cosine, all right? Get your stuff ready to go. Let's handle business. So starting with our do now. Identify the amplitude and period of 3 sine 4x, and then identify the amplitude and period given the curve below. And I have put over to the right a times sine of bx for you guys as just a little reminder. So we have two situations here. Both situations are asking us to identify the amplitude, and both are asking us to identify the period, but the first one is given in an equation, and the second one is given a graph. Okay? So let's do this. Given an equation is very straightforward. Okay? You're going to use this equation right over here, and the amplitude stands for A. It's the number in front of sine. So we just look here and we're like, oh, would you look at that? Would you look at that? For this equation, our amplitude is equal to 3. Okay, it's just that right in front. Amplitude is equal to 3. Very straightforward. Check. Now we need to find the period, which the period is how long is the wavelength. It's that horizontal versus amplitude is kind of our vertical distance. Our period is our horizontal distance. Now, you'll notice that this equation does not give you, the letter P does not appear, but B does. And we do know that B can help us find P, and P can help us find B. It's kind of like this weird symbiotic relationship, okay? So we've got B is going to equal 2 pi over P, or P is equal to 2 pi over B, just depending on what you're working with and what you're looking for. And right now, we are looking for the period. We're looking for P, okay? So we can set it up. P is equal to 2 pi over our b value. And we know b. We've got b. b is right there. b is equal to 4. So if we plug that into our equation, 2 pi over 4, 2 over 4 can simplify to 1/2. And then we still had pi on top. So p is pi over 2. Very straightforward. P is pi over 2. It's a little weird, but we found p. Boom. Done and done. Now, I feel like working with the graphs is actually a little bit easier because we're used to identifying this vertical and horizontal distance. So let's rock and roll with this equation, or this graph. Identify the amplitude and period of the sine curve below. And I'm just going to highlight the sine curve again. Starts at 0, ends at 0. It kind of looks like a backwards S or something, or flipped on its sine. So there's our sine curve for sure. And we need to identify the amplitude. The amplitude is the distance from the middle to the top, and the distance from the middle to the bottom. And they should be the same distance. It's the distance from the midline to the maximum value, the maximum height, the midline to the minimum value, the minimum height. And if we count, we can see that this maximum height is 3, and this minimum height is 3. So our amplitude is equal to 3. It's always a positive distance. Period now describes the wavelength, right? Again, it's still going to be, period represents this, like how long is our curve? And if we use this, that's kind of like too thick. If we start at 0 and we end at where our sine graph ends, we literally just look on the x-axis. And period, the length of this wavelength, the period length, is 4. The length of the wavelength is the period. The wave ends at 4. The period is 4. Nice. Okay, so I have a problem before we get into cosine to select the equation that represents the graph below. So we still got sine, but we need to figure out which one represents this graph, okay? Like which graph represents the picture. Which graph matches. So this is actually the same graph that we were literally just working on. So right here's, oops, I don't want to use green. Here's our sine graph right there. There's sine, so we know it's sine. Automatically, 100%, you're out. We don't even know what cosine looks like. We know that the amplitude, this distance, or this distance, was 3. So both of these guys are in. 6 is out. It does not have a height from the middle of 6. It's just totally out. And then we have to figure out B, because our equation has our amplitude, but it also has B, which is how many graphs of sine, how many cycles finish in 2 pi, right? Now, we don't have 2 pi on our scale on the x-axis, but we can use our formula to figure out what B is, okay? B is 2 pi over P, and we already figured out what our period was. The period length, the wavelength period, was equal to 4, right? Because this distance was 4. So we can easily figure out B. B is going to equal 2 pi over 4, and that gives us pi over 2, okay? And so we need to find anywhere, I should have written that in red, but whatever. We need to find anywhere where B in front of the variable in front, or the number in front of x, is pi over 2. That's not pi over 2. This one is, so that is the equation of our graph. So, in your own words, I need you guys to describe what amplitude is on your guided notes. What is a period in terms of a periodic function? And what is B? Go ahead and recap really quick. What are those things? And I'll tell you. I'll just tell you. Amplitude is the height from the middle. the height from the midline. Every single time your amplitude, you're going to find your maximum height and your minimum height. See what they are? This one's 2 and -2. That tells me the middle is 0. And we represent our amplitude like this. Amplitude is really the vertical height. The height of the function from the midline. Period. What is period? Period is the wavelength. It's this horizontal distance. So our period is the horizontal distance. How long does it take to finish one cycle of sine? How long? Okay, each of these is all one of those. B. Now B is the tricky one. B is the number of cycles from 0 to 2 pi. How many cycles of our graph finishes between 0 and 2 pi? Okay, so that's where you literally have to, like, we're gonna like draw almost like a border where we'll always start at 0 and then 2 pi, and you're gonna count. If you have a graph, you're gonna count how many cycles are there. Start at 0, end at 2 pi. How many cycles is between 0 and 2 pi? That's what B measures. B is very closely related to the period. And if we do this, we're like, okay, let's check. Here's one graph of sine. Here's a second graph. There's a third graph. And it looks like in this fourth graph over here, or in this top one, that there appears to be 4. So for this top one, B is equal to 4 because we have 1, 2, 3, 4 within 2 pi. If we look at the bottom graph, it doesn't even finish an entire cycle of sine, right? Sine continues on all the way down here. It only finishes half of it, but that's okay. We can still say that B is equal to 1/2. B is the number of cycles that occur in 2 pi. Okay, identify the amplitude and period and sketch the graph. All right, so we have 4 sine pi x. 4 sine pi x. So we're going to first start off by identifying the thing straight up from the equation, okay? Amplitude is the easiest. It comes in front of the sine, in front of the trig function. So our amplitude is going to equal 4. And that means our max height is going to be 4. And our minimum height is going to be 4. I'll let you know when that changes when we get to those shifts and stuff later on. But right now, we're always going to assume it's starting at 0. It has a maximum height of 4 and a minimum height of 4. Now, that means that the maximum height we're going to go on our graph is up here at 4. And the minimum is 4 as well. So you can kind of like think of this as barriers, like where a graph can go, where a graph can live between. It actually relates to the range of our function, domain and range. Period. No, period. That is our wavelength, right? But the wavelength isn't given in our equation. Actually, B is given in our equation. But we can find the period if we have B. That's going to be 2 pi, right? Over B. And so we were given that B is pi, so it's 2 pi over pi. That means our period is going to be 2. So our graph, if we're going to do one cycle, it's going to start at 0 and it has to end at 2. It has to end at 2. And we're also graphing sine, okay? Like we're graphing sine. So our function has to start at 0 and end at 0. And our sine graph always goes up first, goes into the middle, goes down, and back to 0. So our sine graph actually looks something like this. That's what our graph is going to look like. And based on this information, we can see that we kind of had some restrictions to our graph. So now the question is, what the heck does cosine look like, okay? What does cosine look like? And we're going to need our unit circle, but really just 4 key points. Instead of what we did with sine, which was graph 16 points and then notice a pattern. No. We're going to, the same pattern works, okay? They're periodic. We're only going to need 4 points. So I'm going to draw like a little sketchy unit circle over here. And we really only care about 0 radians, pi over 2 radians, pi, 3 pi over 2 radians, and also 2 pi. Okay? And those come with really easy coordinates. So I'm actually going to mark these in like a different color, so it's a little bit easier to tell what's what. And we're going to use those points. So when we're talking about 0, that means 0 rotations. We're looking at that coordinate right here. That coordinate is x is 1, y is 0. Okay, that's this coordinate right here. X is 1, y is 0. And if you remember, cosine is the x value. So I want the x coordinate. When we're at 0 radians, cosine is 1. The value is 1. Then we're going to move to pi over 2, okay? Pi over 2 over here. That coordinate is 0, 1. That's this coordinate right there. Again, cosine is the x value. So at pi over 2, we have this coordinate. We have 0. At pi, that coordinate is -1, 0. And we care cosine is the x value. So I want the x coordinate, meaning when we have cosine of pi, that's 1. That's really what I'm doing. I'm taking all of these values right here and creating an input and figuring out what the output is. At 3 pi over 2, way down here, that coordinate is 0, -1. So when I have cosine of 3 pi over 2, right, that means the x coordinate, because cosine is the x values, our output is 0, just like that coordinate. And lastly, when we finish at 2 pi, we went around the circle. 2 pi, we're back to where we started. So the output will remain the same, 1. And when we graph this, we will always label our x-axis first, where these are 1, 2, 3, 4, pretty much, well, almost. I labeled this kind of weird. This is 4 equal parts. From 0 to pi over 2, that's 1 part. From pi over 2 to pi, that's 1 part. From pi to 3 pi over 2, that's 1 part. 3 pi over 2, that's 1 part. So we need 4 equal parts. And this one's already there. So we start off, I always label 2 pi first. Cut that in half, that's pi. Cut that in half, that's pi over 2. And then I count 1 pi over 2. 2 pi over 2. I find out this label because I'm counting 3 pi over 2 and then 4 pi over 2, or 2 pi. Then it comes time to label our y-axis, and that is going to depend on these heights right here. So the maximum height is going to be here at 1. The minimum height is going to be here at -1. And we're going to graph this as this is an ordered pair, like x is 0, y is 1. So when x is 0, y is 1, that's this point right here. When x is pi over 2, y is 0, that gives us this second point. When x is pi, y is negative. Oops, that actually needs to be down here. That gives us our third point. When x is 3 pi over 2, we're back to 0. And when x is 2 pi, we're back up to 1. Okay, so that gives us these 4 points. And this graph, I want you to think of connecting all of these points. It's not gonna look like a V, okay? That's definitely what it's not going to look like. Excuse me. All of these graphs are curvy. Curvy, curvy, curvy. Okay? So if they're curvy, we have to think of them in terms of like what a curve is going to look like, and they're all like, it's kind of coming from the unit circle anyway, you guys. So think of these as being like creating quarter circles, right? So like here's a quarter of a circle. From here to here, oops. Here to here is a quarter of a circle. From here to here is a quarter of a circle. And from here to here is a quarter of a circle. That's how I draw my cosine graphs, as like little circles, so that I get that nice curvy shape. And this, ladies and gentlemen, is a cosine graph. Okay? Cosine starts with the letter C. One of my favorite music artists, well, she's not really my favorite, but like I like her stuff, right? Cosine starts with the C, and there's a very famous female rapper, okay? And her name also starts with the C, and I'm going to make this trig match with her, okay? So the female artist that I'm talking about is Cardi B, none other than Cardi B, y'all, okay? And Cardi B and Cosine, they are together. We are going to make this association, Cardi B and Cosine. I don't care if you don't like Cardi B, whatever. You're gonna hear nothing but our new hit single, Cosine. Okay, so Cardi B and Cosine both start with C, and Cardi's got a very famous song called Up, right? If it's up, if it's up, if it's up, remix, then it's cosine, okay? That's how we're going to remember the difference between sine and cosine. Because our cosine graph, when we're out here looking at when x is 0, we started up at 1. And if we started up at 1, we had to end at 1. So this is how we're going to remember cosine, the cosine graph. If it's up, if it's up, if it's up, then it's cosine, right? So if we're starting up here at 1, not down at 0, sine started down at 0, y'all. Sine started here. Sine went like this. The sine graph looked like this. That's not what we have right here. We've got cosine. If it's up, if it's up, if it's up, then it's cosine. Okay? Then it's cosine. So that's how we're going to remember what this graph looks like. This is how we're going to remember where this graph starts. We are attributing trigonometry and Cardi B and our graphs all together, and we're going to be a freaking boss at it, all right? So we are going to draw. I gave you guys pictures of these graphs. We are going to visually represent amplitude, period, and B, and then we're going to put it all together. We're going to write them out and put it into our equation, okay? We're going to practice this for a little bit. So here, in fact, is a cosine graph. You know how I can tell it's a cosine graph? Because cosine starts with C, the letter C, and this rap star, Cardi B, she starts with the letter C, and if it's up, if it's up, if it's up, then it's cosine, right? At x is 0, if it's up, then it's cosine, right? And it's going to end upwards. There's our cosine graph. So what I want you guys to do is, one, if you can, highlight the cosine curve. It's going to help us with muscle memory. But two, we need to demonstrate the amplitude, okay? So the amplitude is going to be from the maximum height and minimum heights to the center. So you're going to do something like this. I want to physically see, when you guys turn in your notes, this representing your amplitude. And we're going to describe the height of that amplitude, okay? Amplitude, height, is equal to, now we got to like interpret this graph, which is a little tricky. So here's 0, here's 2, we're not in the middle, that would be 1. But we're halfway between 0 and 1, so our amplitude has to be 1/2, okay? And if we look down here, that's going to be negative 1/2. This is negative 1. This is negative 1.5, negative 2, right? So our amplitude is 1/2. I want to physically see you guys with your amplitudes on there. Then period. Period is the wavelength, that horizontal distance. How long? So I want to see starting at 0 all the way to the end of our graph. I want to see this representing the period. And how long is it? You literally just look at the x-axis. P equals 2 pi. P equals 2 pi. Okay? Now B is silly. We can use this formula. B is equal to 2 pi over 2 pi, and that gives you 1. Or literally there's only one cosine graph from 0 to 2 pi. So same visual. There's only one cosine graph from 0 to 2 pi. There's not more than one. There's only one. Let's do another. Okay, here's another graph. Again, I need to identify amplitude, period, and B. Oops, I forgot to put together the equation in this last example. I'm a liar, all right? So transitioning back, if we're going to come up with an equation, our amplitude comes first. That's 1/2. Our trig function comes next. If it's up, then it's cosine. Then comes B, which was 1, and then the letter X. So we can simplify this to 1/2 cosine of X. That extra 1 is not necessary. Now we can move to the next one. Amplitude. What's the amplitude? We got to find our maximum height, which is 2. Our minimum height, -2. So